Hello.
Hello, sir.
Hello. Yeah, good. So, not everybody is here, but some of you are here. Um, okay. So, okay, let's wait for some other people to come in. Uh, so, almost all of you are new to ISI, right? And you have not even seen ISI possibly. So, yeah. So just one kind of protocol for this Zoom meeting is that, of course, when you enter, you will be kind of muted on automatically, and in general, you can mute yourself whenever you, I mean, almost all the time. But if you have at any point of time, if you have a question, feel free to unmute yourself and shout out. Okay. You can of course send me chats. Sorry, somebody told something I cannot hear.
আপনি আমাকে দেখতে পাচ্ছেন? Can you see me?
Sorry, I can see one person. I don't know, but I don't need to. Who are you talking? Can you just say your name?
I'm Aritro.
No, I mean I am. Yeah, you don't have to put on your video. I can hear you. I cannot see you, but that's perfectly fine.
But I can see you. Okay.
Yeah. So I don't need to see you guys. In fact, I mean you also don't need to see me. But I've still put on the video, and very soon we will go into the share the screen and all. So yeah. So okay. So before we start, I mean, of course, it's a very weird formal introduction over the Zoom. It's not a class to class face to face interface. So. So let's start with, how do you think about, I mean, what has been your experience in the last one day of this Zoom classes till now? Yeah. Yeah, you can unmute yourself and say.
Yes, sir. Good morning, sir.
Yeah,
good afternoon also.
Yeah, good afternoon.
So it's going well. Yesterday we had 3 classes, and last classes we have C lab, and that was quite well, and we have algorithm classes also.
Right.
That was also good. And
But,
first class our
okay. And technically, is there any problem? Meaning, it kind of the Zoom and all in that respect?
Actually, frankly, in DA, Malloy sir had some issue with whiteboard and
Okay.
like that. He had some technical issue with his pen.
Okay.
He will manage. He said that he will manage.
Yeah.
The only issue, sir, I think right now we have is that sometimes the classes could go till 7:20.
Yeah, so Arijit Vishnu particularly has a problem with that. I mean, he tends to overshoot his short times in general, even in a physical classroom. So if you are tired, don't be afraid and just shout out that we are tired. Can we not have it now or something? I mean, it's true for every time, okay? So one thing that you guys, many of it might be coming from different institutes where a different culture exists and all, but here I should make it very clear, and this is true for every class that you attend here, and you can take my word, nobody will be offended. Here, it is very important that you ask us questions. Yes. If you don't understand something, stop us, okay? It's your job is to put in the effort, but if you don't understand something, that is our fault, okay? Be very clear about it, that okay, I'm not understanding it. See, at the worst, what will happen? Maybe you're still not understanding and pulling the class back. In that case, the teacher will of course say that okay, fine, maybe you are not understanding it, let us discuss this one later on, one-to-one or something like that. That's the worst that can happen, okay? But that is way more important than not following something and continuing with the classes, okay? So,
Yes.
and I am repeating it again, particularly in this setting. See, in a classroom setting, when I can see you guys, it's a very naturally I can understand whether something has been clear to you guys or not.
Mhm.
Okay, but in this Zoom setting, when I cannot see your faces and all, it is very hard for me to understand whether somebody is having difficulty or somebody is not understanding everything perfectly and so on. Okay, so in that respect, please, I mean, it is your responsibility. I mean, yeah, I mean, it's always your responsibility to learn. It's always your responsibility to ask, but also in this particular this virtual classes situation, this is much more important. Okay, I mean, you cannot bank on us to slow down if you have not understood something. You have to tell us that I have not understood, and only then we will slow down. Okay, if you think that something is going too slow for you, also you can say something. Oh, this is too slow for us. Can you go fast? Okay, feel free to say. Okay. Yeah, the other thing is that I mean, from personally from my point of view, I can say that I would prefer to be called by my first name rather than Sad or anything. Okay, you can call straight away by my name, Saurav. Don't worry about it. It is perfectly. I mean, that's the most natural thing that I would like to happen. Okay, so okay. Okay, I'm sure we will face a lot of issues that will come up as and when we go about this particular setting of the whole stuff now. Mm, okay. Okay. So I know that now there are 60 people have come, so 50 people have come, which means that there are some GRS have also joined here. Uh, so it's a big class. Okay. I will tell you again, but again I will. But let me state the beginning only. Since it is a virtual thing, you have to put in way more effort than what one needs to put in normally. Okay, that is something. I mean, I cannot stress less here. Okay, I mean, so we will be trying to give you problems, assignments, um, discuss stuffs and all, but it is your goal to keep on working on them. If you don't understand something, we'll have number of different channels through which you can reach us. Okay, where I would request you guys to come to us and say, okay, there'll be TAs and there will be, I mean, I'll be there, and everybody of you, there's the classroom where you can post stuffs and all. So please use those mediums and try to be as interactive as possible. Okay, and things will be, everything will be posted. I know there will be some internet issues with many people. We will try to make it up. If you still, I mean, if you have any problems, let us know. Okay, and we will try to solve it in the best way we can. Okay, so before I go into further into the technical stuffs, I want to ask you, I want to get some polls from you, some information from you. Okay, so let me. I will just launch some polls. There are 3 questions that are there, and give me some idea about. I mean, how you are accessing this internet and all those kind of stuff. So I have launched it. I mean, maybe you can. There are 3 questions. Okay, you can go down as. Yeah, this by this the lectures will be recorded, and the recorded lectures will be uploaded in the YouTube channel. Okay, I think I get some idea. So the best part is that somehow almost everybody of you, except for one person, or two or 2%, seem to have very good internet connection, which is something very nice. Excellent. Okay, I think I got some overall idea about what's going on. I think I will stop the poll now. Okay, so for people who have not checked out the web page and the YouTube channel and the classroom, okay, I will request you guys to do that. Okay, everything of us, our communication will be through those three things. Okay, every lecture after it is being done, the video will be uploaded in the internet, in the YouTube channel. Okay, the link for the video and the notes and slides and whatever stuff will be uploaded in the web page. Okay. Any announcement that has to be done quickly to you guys will be done through the classroom. I don't think I will be using the Google group email or something, any of the stuffs as such. Anything will be done through the classroom. So because once I send something into the classroom, then you will be getting it automatically in an email. And you guys are also encouraged to, if you have to ask something, say you answer, oh, I didn't understand this part, or something like that, please write it in the classroom. Okay, in the classroom there is a stream thing where you can also upload anything. Okay, and through which we can get some information about. Okay, so I can prepare for next class. Or, okay, this part is something that we have not got it, or something. And also more importantly, the I mean, okay, you guys, I possibly don't even know each other, right? You guys have not even seen each other. So one big place where from which you do get a lot of knowledge is by talking to your friends, discussing with your friends. Unfortunately, that is not happening right now that much. uh, but still I will encourage you guys to kind of have a discussion, maybe through the classroom forum or something. So if somebody says that I didn't understand this part, if somebody else have understood it, go for it. Okay, the reason is that I will explain stuff, no doubt about that, but then there will be times when possibly if somebody else explains something, somebody else explains something that might be easier for you to understand. Okay, I mean, hearing from different. But by the somebody has asked me, Somrita Bokshi. So can are you Somrita Bokshi? Are you
Orkodi Bokshi.
Oh, you are Arkodi Bokshi. Okay, so are you a JRF or a?
It's a JRF.
You're a JRF. So you must have got the. So there's a Google Classroom. That is what I'm talking about. Okay. And in the Google Classroom, your name should already have been uploaded. Okay, and you have to kind of accept it. You must have got an email saying that, I mean, accept it or something like that. Yeah, another thing that is, this is something, I mean, I will ask it, but unfortunately, I never is it followed, no years, but still I will ask it. JRF students, right? So for master student, it doesn't matter. For master students, you are anyway have to attend this class. For JRF students, some of you might not want to take this class because this is not a compulsory course for you. Okay, and your name is possibly is still in the classroom or something like that. If you plan to not take the class, this lecture, okay, please drop me an email. Whenever you decide that, oh no, I will not take this, I will not take this Discrete Math this year, please drop me an email. I mean, I cannot force you, but that's a kind of a, I mean, it'll be kind of a courtesy thing. I will not be offended at all. It will help me to kind of understand what is the situation of the class strength and so on. Else I'll be very confused. Okay, so good. So Yeah.
Everyone, sir.
Sorry. Yeah. So the YouTube channel and Mayank Deora, are you a JRF or a M.Tech students?
Sir, I am JRF student.
So all of you must have got a mail from me which had this Zoom link.
Yes, sir.
So in that mail, this YouTube channel, the web page link is there.
Okay.
Okay. The web page link is there. Yeah. Anyways, your friend Somudip Shah has uploaded it also.
Okay, sir. Thank you.
The YouTube channel link is also there. Okay, good. So, okay. So before I go further again, I need to take one more poll. This is a more technical poll. See, I know that you guys are coming from various backgrounds, right? With a various different exposure to these subjects. So I just need to know which all subjects have you been somewhat exposed to. Okay. So here is this one. Sorry, yeah. Okay, excellent. So it's like most of you have been introduced to most of them, not all of you, okay, fine, around 2/3 of you. Okay. Okay. Okay, so let's me start then with I get some idea about these things. Let me start with a basic introduction to um, discrete math. So the first lecture. And oh, by the way, you guys have this is a two lectures, right? That you have.
2 lectures.
I mean,
Yes, sir.
this is a two lecture thing. So this is like a how much? 1.5 hour and 1.5 hour or something. What did I forget actually? No, 1 hour and 1 hour.
No.
50
Yeah,
minutes.
50 minutes. 50 minutes.
50 minutes anything. Okay, so I don't think I will take a 50-minute and 50-minute thing. Almost none of the classes. Okay, because I think this kind of breaks the whole rhythm. Instead, what I will do is that I will not be taking 2 hours of whole lecture. Most of my lectures will be something between 1 hour and 1 hour 30 minutes and stop there. Okay, any problem with that? If you guys have any, I mean, if you prefer a 50 minute or something, you can let me know. But
Yes,
I think breaking up in the middle is not going to
No,
yes,
sir, it's okay.
take.
yes, sir.
Okay.
no problem.
Okay, so let me start with, so whatever we are going to do today is just a very basic introduction kind of stuff. So can you see my screen?
Yes.
Yes.
Excellent. Okay. So good. So let me, I mean, again, it will mostly be about the setting up the course and all. So first of all, you know that there will be 2 lectures per week. Some of the days we might have 3 lectures. Okay, for example, this week, I think on this Saturday, you have the Saturday 2 to 4. You guys have the linear algebra course, which is not going to happen this week. So this week, Saturday, we will have an extra class of discrete math. Okay, it will be in this Zoom link only. The same Zoom link will work for throughout the whole semester. Okay, so there are 3 TAs for this course. So TAs, I don't know whether you guys have, all of you are familiar with the concept of TA. TAs are teaching assistants. Okay, all these three TAs are second or third year JRS students, PhD students. They are Shayantan Shen, Chandrima Kayal, and Shoumi Nandi. I think all of them are currently attending this class. Shayantan, Chandrima,
Yeah, Saurabh. Yeah.
so all of you are there, right? And Shoumi,
She's also there.
she's also there. Okay, fine. Okay, so you will find, so all of you, means all of you meaning all of this, the attendees, so their the names and the email addresses of the TAs are given in the web page. Okay, and you don't need to write to them directly as such, but you can use their emails if you need them. And so they will be they will be there for helping you. Okay? So if you have any doubts, any questions, any particular problem that you have seen, you cannot solve it, or how to write something, you can of course write that to me, tell me, but it will also be good if you tell them, because they will give a different perspective of this stuff, of the explanations and all. Okay, so please use them as much as you can for gaining knowledge more. Okay, and now here, yeah, so this is what I told. Don't hesitate to ask questions to TS.
May I ask you one thing, sir?
Yeah.
How can I communicate with the TAs?
Can you just, when you say, can you just say your name actually to start with, and then, then say the question?
I'm Auditro.
Okay, I mean the emails are there, right? Email address of TAs are there, but it will be, I mean, it will be better to ask them kind of pointed questions like, okay, here is the problem, I cannot solve it. Can you help me?
I will do that.
Yeah, you can also post it in the Google Classroom,
yes, you
so
can
that
also,
everybody can see.
Okay, thank you very much.
That would help. Possibly, if someone else also have that problem, it will be resolved.
Okay.
Yeah, I think that will be the better thing. If somebody is having a doubt about something, first post it in classroom, so that everybody gets to know that, okay, there is a problem like this. Yeah.
Sir, can you repeat the thing that you have said for 3 TS? I didn't listen because of some connectivity issue.
No,
what
I
are
just,
these 3 TS?
So these 3 TS are there to help you. Okay, it's like other than me, there are these 3 people who are there to help you in various doubts, clearing out doubts, helping you with problem solving, helping you in how to write a problem. Okay.
So we will get the email IDs for.
They are all in the web page. They are all on the web page.
Okay.
You go to the web page, the whole details are there. Okay, so that is, so you should go and check out the web page. Okay, and it's very important because the web page will have all the information. Okay.
Okay.
Yeah. Now discussion among yourself is highly encouraged. Highly encouraging. I cannot, I mean, stress on it less. Okay, so of course you can use the Google Classroom. Even otherwise, say like after the end of this class, you guys have a class after this, right? After this discrete math course.
Yes.
Yeah, but
that
that
starts CO course.
Right, that starts at 4 o'clock or something like that, right? 5 o'clock. Okay, so this course will go on till say something like 3:30. No, this particular course will go on till 3:30 or something.
Yeah.
Okay.
Yeah.
Now, if you guys want to hang out in this Zoom link only and talk to you, all of you friends and all, discuss stuff, I will be happy to let you guys know. Okay. I can allow. I mean, I will log out myself, but this Zoom link will be open and you will be free to discuss on whatever you want there. Okay. So you can. So this or any other things, please discuss. Okay. If you have any doubt, the person who will be the people who will be able to solve your doubts quickly and the most effective way are actually your friends. Okay. Okay, good. Now, okay, this is a particularly this discrete math course, okay, has two components to it. One component is to learning the new concepts, learning new theorems, and so on and so forth. Okay, but then there's another part of it which is actually about solving the problems, writing solutions. Okay, this is something that many of you would have not seen for quite some time. Okay, so just vaguely understanding what is the correct solution is not going to help you always. Okay, you need to write it up, give a formal proof of something, and so on and so forth, right? So the only way this can be done, both the solving the problems and the art of writing the problems, proving the problems formally, the only way you can do is by trying out problems after problems after problems. Okay. We will give you the theory, we will give you the ideas how to go about it. I will give you the tricks and all to something, how to handle some problems and something like that. But unless you solve lots and lots of questions, you will not be able to understand anything of this course. Okay. At the end of the day, it will be completely be wasted. Okay. So you have to do a lot of problem solving. There are a number of classes, sessions will be dedicated to problem solving. Like maybe the TAs will take it, or maybe one of them, a few of them I can take it, which will be like solving the problems. Even almost a daily basis classes, the regular classes, I think we will spend every class first 30 minutes or something to kind of discuss how to solve some problems and so on. Okay. And so there will be lots and lots of exercises that will be given. Okay, many of them exercises might not be officially be kind of formally written up or something, but while in the middle of the lecture I will say that, okay, see, here is the problem, go and try to solve it yourself. Okay, and these are the exercises that you have to solve it yourself. You don't have to submit it. If you want, you can send us the solutions and say that, can you please verify whether this solution is correct or not. We will be happy to do that, but you are not required to do that. But it will be good for you if you do them, meaning solve them by at least by yourself. Okay. Problem sets will be given. So there will be two kind of things. There will be kind of something called a problem set, which is basically a set of problems that will be given, and they are all for your practice. Okay, and they will not be graded. You don't have to submit it. They will officially be posted in the web page. If you look at the web page regularly, the problem set will be uploaded there. Okay, and your job is basically go over them, try it out, discuss with your friends, try to solve it yourself. You don't have to submit it, but they are all for practice. Okay. Now, for the thing that you have to submit, so for the thing that you submit, there will be the assignments. Okay, that's a separate one. So the assignment will be given once in every 2 weeks. Okay, I mean somewhat like that. So basically, you should expect something between 6 to 7 assignments in this whole course. Okay, each assignment will be some 6-7 problems, and I mean by default you can think of it that every assignment due date will be 1 week. Okay, sometimes I mean I'm sure you guys only will ask extensions and something like that. It might go on till 10 days or something, but more or less week. Okay, and this assignment will be graded. So this set of assignments, you have to do it by yourself. In the solving of assignments, we will discourage you to discuss among yourselves. Now again, in a course like this, when everything is becoming online and all, I mean, I cannot insist on anything, right? I mean, I don't know how to check or verify your honesty and all, but I mean, I have to kind of believe whatever you are doing, right? So you are expected to solve it yourself. Will help you to understand whether you are understanding anything in the course or not, or where you stand in the course. Okay.
You get help from other students. Can we mention their name? I mean,
So if you are actually taking some help from other students, now by students you mean if you discuss your problem with another fellow students, okay, then I would say that yeah, you can mention their name. That's the more honest thing to do. But say that okay, this is the person, this thing I have discussed with this person. Although I personally not encourage you that much, okay, for these assignments, because at some point you will do something by yourself, right? But in any case, don't for these assignments and this, even the exams and all, try not to take help from something like some other people, some seniors or something. So that would be very. I mean, at the end of the day, it is your responsibility to learn it. I can only do that much help to learn it for you to learn. Okay. I mean, a grade is not the only thing that matters. I mean, if all of you say that, see, sir, all I want is 100 out of 100 and nothing else, I will be happy to give you 100 out of 100 and say that, okay, this course is not there. Done. But I hope that that is not your goal. Your goal is to learn something, right? I mean, the marks is secondary to some level. And I mean, ISI's whole goal is kind of set up in that way. That this is how you are supposed to. Okay. Again, as I told you, a lot of this focus will be on the writing, and that we will take a lot of special care on that, of how to write, what to write, and all. I will say it a bit more here now. Okay, so this is something that you learn with time. Okay, it's the kind of a thumb rule. Whenever you write a solution, that solution should not be too much English dependent. It should not have a lot of huge words explaining things and all. Okay. Yeah. So, by the way, can you guys? I mean, whoever is not talking, can you just mute yourselves a bit? Because there's some background noises coming. Okay. So, okay, good. So, so you have to do it. So you have to learn the art of writing things formally, okay, without writing too much of English. Okay. So this is something that I mean I can only explain it more as the problems comes up, and you will see it more about it. But this is a thumb rule that you should always have that try not to give a solution which is a lot and lots of explanation in English. Mathematical accuracy, preciseness is what is the need of this hour. Okay. Okay. Now here is it. All the assignments will be posted in Classroom. Now, if you go to Google Classroom, you will see that there is a place where you can download the assignment, and then you can upload the assignments, the solutions when you are done. Okay, that is fine. But every assignment is something that you have to write, not in pen and paper on a paper, but you have to write it digitally. This one I insist. Okay. Every year in the MTech course, this discrete math course, I really make you guys learn something, particularly around a part of writing something. Okay? And one of it is LaTeX. Have you guys heard of LaTeX? How many of you have heard of LaTeX?
Yes, sir.
Yes, sir.
I've used it.
Yes, sir.
Yes, sir.
In the other course or before this, previously only?
Previously only.
Okay, previously only you have heard of LaTeX. Right. Okay, good. So whoever knows LaTeX, perfectly fine. Whoever doesn't know LaTeX, you learn it.
Okay.
Okay, it's a very simple writing thing. It is basically a software free of cost available. There's no cost involved at all. Okay, and it is the standard way of writing stuff mathematically. Okay, Word and all, you writing mathematical stuff in Word and other Notepad and all those things is slightly complicated. So this is something that you have to learn, and I want you to submit your assignments in LaTeX. Okay, so if you want a particular format for this LaTeX stuff and all, I mean, the TS can help you, give you a overall format. I mean, overall the header and all those things, or maybe a kind of a sample one solution or something like that, with which you can start this stuff. Okay, so I think the first assignment will not come in the first week, so it will come in after a week or so. So you have 1 week to kind of get used to LaTeX, download LaTeX in your computer, do some and get and learn through how to write the small simple stuffs and all. Now, if somebody doesn't have access to computer, okay, or at some point of time somebody suddenly says that I don't have good internet connection to even download some stuff, so these technical issues, if they come up, then please write to us individually. And okay, see, I mean, this is the technical problem I'm facing. We will, of course, consider you and accordingly try to work on it. Okay, but that will be a case by case basis. Okay, so if you don't have a big computer or don't have a computer and you're like, I mean, you are asking me to submit stuff in LaTeX, how will I do it? I don't have a computer. Okay, we will think about something. But your case will be special in that case. Okay? And so don't be panicked if you have some technical issues or you don't have something. That is not your fault. Everything will be fine. But if you do have these options available, then do please learn how to do it. Yeah.
Sir, I am Orithro.
Yeah.
May I ask you something?
Yeah.
Is it more important to solve the problems, or it is more important to write in LaTeX? Which do you think is more important?
Both.
Both.
Yeah.
The problem I solve kar do. I can solve my problem by own effort.
Okay, this is a course in ISI. Okay, only English is allowed here.
I'm sorry. I can
Okay,
speak both.
and Orithro, I mean, if this kind of questions, I can understand that you are not. I mean, if you have questions of this kind of sort of what is more important, this kind of philosophical debates, let's not have it here.
I'm sorry. I'm so sorry. Sir.
Okay.
I'm really sorry.
Good. Now comes the final exam. Yeah. So there will be no midterm. This is possibly you guys have heard of it. Okay. That there is no midterm. So there will be an exam at the end of the course. The syllabus without, I mean, I don't even have to say it. It will be everything that has been taught in the course till then. Okay, I mean, everything will be taught in the course. The final exam will be of 40 marks. Okay, and the remaining 60 marks will be based on the bi-weekly assignments.
Okay.
Okay, so I might end up taking not all the assignments. Say if I have 6 assignments that have been posted and you solve them, I might take the best of 5. Okay, but yeah, something like that. Okay, I will try to ensure that you guys get the best grades. Grades is not the important stuff here. Okay. Okay, good. So this was all of the technical stuff about books and references. So as such, unfortunately enough, this course structure and the topics in this course is such that there is no single book that covers everything that I want to cover.
It's true. Okay.
So which means that, Orithro, can you please mute yourself?
Okay, I can mute myself.
Yeah. So as such, there is no textbook that will be used throughout the whole course. Okay. But there will be some notes, various notes, some books and so on that I will be posting at various times in the web page or in the maybe the classroom or something like that, which will be used for certain topics, subtopics in this area. So right now, if you go to the web page, you will see that I have given you a link to a discrete math book. Again, It will just be there. I mean, it's not necessarily that you have to do it. Okay. Because I mean, rather it's not that you have to get it or I'll follow it line by line. It's not the case. But also, this book is something that I think is available online, soft copy, though possibly not in a very legal way, but that's okay. I mean, try to get one pirated copy somewhere if required. The other thing is, yeah, there will be notes that I will be uploaded. There is a note by Laszlo Babai that I have already uploaded. That is something that I personally like a lot. But that note is have good set of problems rather than set of the content is a bit terse. We'll upload more and more things as we go. Okay, so this was everything about the technical aspects of the course. Is it clear, or is there some doubts, questions? Hello. Yeah,
Yes,
yeah. If you want to say something, you have to kind of unmute yourself and say it, because else I'll not be able to. Yeah. Okay, good. So,
Yes.
is it fine? Hello. Somebody was saying something.
Yes, clear, sir.
Okay, perfect. Yeah. Good. So, okay. So now let's go into the actual course. Okay. So, yeah. So let's start with this thing. You are doing this course, discrete math, right? What is discrete math? I mean, what do you expect from this course? Why is so? You may unmute yourself and just say whatever, shout out if you got, or send me chat or whatever. Oh, somebody asked how to learn LaTeX. Okay, we can take a call on that later. They don't have to learn LaTeX. LaTeX is something very trivial.
Should I answer my view? Can I explain my view?
Yeah, go ahead.
Look, discrete mathematics is a very broad subject. It has a different point of view. If you look for basic structures, it is counting a group of members in a committee, okay, counting a number of paths, stuff like those.
Okay,
For
good.
the beginning.
Okay. What was the rest actually? There's some how to prove things mathematically. See, somebody says that how to prove things mathematically. That's a good thing, that how to prove things mathematically. But then why discrete? I mean,
sir, in discrete math, we don't deal with continuous numbers. Here, the solution or in the problem area, what are the numbers we deal with? They are discrete. If we plot on a graph, that will not be a line, all the solution or all the problem sample point.
Okay, good. Okay. Okay, so yeah, so broadly speaking, I think all of you, whatever you told is kind of right, okay? So discrete math is, first of all, discrete math doesn't exactly have a very concise definition, okay? It's not like algorithms, it's not like topology, it's not like, say, quantum physics. Okay, it's not like an area that is kind of, you can define it clearly, and this is possibly also the reason why discrete math doesn't have a book, right? Can you have a book on mathematics? Of course not. You cannot have a book on mathematics, because mathematics is everything. Similarly, discrete mathematics, it can have a lot of things, but basically, discrete mathematics is something that is very important to us, and we do study discrete mathematics as a separate subject because of certain usefulness. Let's see. Okay. So, discrete math is study of discrete objects, as someone of you pointed out. So, what are discrete objects? So, discrete object is something that is not continuous. Good. Okay, that was not very helpful, possibly, but still. So something that's countable. Now, this concept of countable is something that we will see a bit more later on. But something that you can count. Okay, this is the first object, second object, third object, fourth object, fifth object, like this. Okay. So let's see some examples. Okay, these are the examples of non-discrete object. And somebody pointed out the real line. No, it's not discrete. So there is no something called a first point. There is no something called a second real line, right? What is the first real number? What is the second real number? There is nothing like that. Okay. Similarly, the plane, the overall plane, the real plane. Okay, or things like numbers which are a bit complicated, right? Which are not very easy to kind of write out. Okay, something like the pi, or some continuous functions, say something like y equals to x cubed, where x and y are both taking the real values. Okay, these are not discrete. Now, what are some examples of discrete objects? Of course, I have some things, objects, right? People, chair, table, balls, students, baskets, whatever. They are all discrete, right? Integers. This is a very important discrete object, right? 1, 2, 3, 4, 5, 6, or minus 1, minus 2, minus 3, minus 4. They're all discrete. I know which is the first one, which is the second one, and so on. Rational numbers. Now, rational numbers are what? Rational numbers are what is the rational number? It is the ratio of two integers, right? A by B, say 2 by 3, or 59 by 117, right? These are rational numbers. Rational numbers are numbers that are ratio of two integers. Okay. Yeah, so somebody says, in what sense is pi is not discrete? Okay, we can discuss that one a bit later. Okay, so I will come to that. Okay. But, okay, so you have the rational numbers. So they are, you can think of they are discrete. Why they are discrete? They are discrete because it is a ratio of one integer by another integer. But if you remember, I kind of also told that discrete is stuff that are countable, meaning there is a first number, second number, and so on. In the case of rational numbers, can you do that? Is there a concept of first rational number, second rational number, or something?
No, nothing like that. But I think because it can, there is I somewhere read that if there is any mapping from a set to natural numbers, then it is countable. And in this case, in rational number, we can have a mapping from two set of natural numbers.
Right.
To
Right. So good. So actually, we will do it. If you are not following what he told, don't worry. But there is a way in which we can say what is the first natural number. We can say what is the second natural number. It is possible. Okay.
With the help of bijective mapping.
Yeah, I mean, formally defining, we have to do it correctly, right? I mean, but there is a way of writing out the natural numbers as a first, second, third, fourth, and so on natural numbers. So they are countable, okay, and they are discrete. Okay, a finite set. All finite sets are countable. Okay. Functions that takes in a value like this, that takes in a discrete set of objects and output a discrete set of objects like this, they are countable. Even equations of the form y equals to x cubed, where x and y are natural numbers, this becomes discrete. So now you can see that by looking at this particular example, at the last example, that the gap between natural numbers and discrete objects and non-discrete objects is very small. Right? The domain becomes natural, it becomes a discrete object. Domains become not natural, it becomes reals or something, it becomes non-discrete object. So as such, in some sense, we are unable to really pinpoint the difference. But note this one, that one of the most important part here, possibly the thing that defines discrete object, is countability. Okay? And I will explain more and more as we go on that where this thing is used. Okay. So I mean, all of you, I mean, just to kind of go ahead of ourselves to some level. So somebody asked, what is n square? Now see, what is n square? If a function n square, is it natural, discrete or non-discrete? It depends on what is n. Is n real or n natural? N is real, then this is not natural, not discrete. So you guys have all done well in your class 2 and so on and so forth, right? You have learned various things, various proof techniques. Can you remember a proof technique that works only for the case in countable situations and not in uncountable situation?
Hello.
Hello?
Yes, sir. Sir, mathematical induction.
Very good, excellent. Yeah. Induction. This is the powerful tool that we have, and we will go back to this thing again and again and again. Okay? So math, you have seen induction to some level. We will see induction much more later on. Somebody saying Pigeon principle. Yeah, perfect. Pigeon principle is another thing. So there are all of this kind of stuff that where you have learned these proofs or techniques to some level in your high school, and all of them use the fact that we are dealing with countable objects. Okay, and that is exactly possibly when I think of it, this is exactly where discrete math and non-discrete math separates. The fact that we can use such hammers like induction, like Pigeon principle, and so on. Okay, and good. So this is what we will be dealing with. Now, why to study discrete math as a separate subject? Why not continuous mathematics? We have nothing called a continuous mathematics, right? Instead, we are doing discrete mathematics. The reason we want to study discrete mathematics is, I told you the result, right? That these discrete objects have some common characteristics. And we can use certain tools for handling these discrete objects. They are not available for rest of them, like mathematical induction, like Pigeon principle, and so on. Right? And so we can treat them a bit separately. But inside this discrete math also, there can be a lot and lot of specializations. Okay, so discrete math is kind of a very vague envelope to talk about a collection of areas of research. Okay? And there are specializations. For example, combinatory, something that you have seen to some level earlier, like we have seen permutation, combination, and so on. But you will see more of it. Combinatories, that's the area. Okay. Finite set theory. You must have seen a bit of it. You will see a bit more now. Now, if people are coming from the mathematics world and all, you will have seen things like the finite group theory. Something, if you are coming from a non-mathematics background, you will be possibly taking the some algebraic structures course or something like that, or linear algebra, where you will have to do finite group theory. Discrete probability. Now, this is the thing. Probability can be defined in a very continuous world, and in that case, we call it a measure theory. Okay, that requires some more complicated stuff. Not complicated. The focuses are different. Okay, I mean, if somebody knows measure theory and all, I can have a chat on that. But otherwise, in the world of discrete probability, certain things become very easy and certain things become more interesting. And so this is treated differently, discrete probability. Again, in this course, we will be not going into discrete probability by much. We will just look at it in a few places later on. But if you guys are not familiar with discrete probability, of course you are. I am hoping that you are taking the probability and statistics course or something like that. Graph theory. This is something that possibly many of you have seen it already. It's again a very special area of set theory you can think of, where we are dealing with relations. Okay, and we will get to this subject. And now there are special areas for Ramsey theory, and there are a lot more. Okay, I will get intro. So in this course, we will kind of introduce you to all these subjects with some amount, small amount, or use some. I will give you the proper references of where you can go and find it. So what you can get from this course is a general idea about how to solve them and a overall directions of how you can do more work in various areas. By the way, here I think it's kind of important to kind of say that this course will have particularly two parts. In the first part, we will be mostly doing more of combinatorics, set theory, and so on and so forth. And the second part, we will be doing a bit of a graph theory. So these two will basically be the things that will be there. It doesn't mean that we will not do graph theory in the first part. We'll do a little bit of it, but not too much. Okay. Now, is discrete math relevant to the world? Of course, it's very relevant to the world, particularly in this modern world, when we do a lot of things with computers and all. We basically deal with discrete objects, and hence it becomes a fundamental stuff in mathematics and computer science. And we will see in various later on chapters and all that how to model various problems in one of those abstract objects is what we will learn about. Okay. And we will see that how a lot of problems can be solved using very good modeling of discrete mathematics. Now, yeah. So the goal of this course is, of course, again, so we have to do everything. We have to talk about every object that we will say. We have to talk about mathematically, formally. But I don't want to harp too much on this mathematically, the formalization here. We will do formal stuff, but not to a level that it's a pain to us. Okay. I mean, we don't want to make it. The subject is very beautiful. So it's not just the formalization that is the part. So I will try to focus. I will do kind of balancing act between making it too formal and making it interesting. Okay. Now we will learn a number of techniques that will help us model a problem in some way, and we learn tools about how to attack a problem. Now this is something that you will see again and again in various places, that there are lots of problems. Their basic structure has something nice in it. So there are lots of real life problems where actually what you are solving is some problem on sets. Okay, so one part of it is modeling real life problems, or modeling problems in various mathematical precise ways. Okay, and this is the first part of it, and the other part of it is to solve them using various tools. Now, this is a place I think where we should be careful here. We'll talk about this one. Okay, that although the problems are actually discrete, okay, the tools to solve them need not be discrete. We will see some examples of that in this course, and I will point it out to various famous results of that kind. Okay, for example, the main work, how many of you have not heard of Ramanujan, MS Ramanujan? Sorry, S Ramanujan. Yeah, is there somebody who have not heard of Ramanujan? I hope not. But how many of you know what he did? Why was he famous? Yeah.
Yes, he sent his research work to professors of throughout the world.
Yeah, what was his research work? That's what I'm asking.
He worked on
Partition
partitions
function.
mainly. I
Partition
think.
function.
Partitions,
Can,
yeah.
sir, sorry to interrupt. Partition function.
The infinity
Partition.
research work something.
For that, he
Summation
was
of infinite
also
series.
Infinite series.
Infinite
Yeah.
sets, yes.
he has also given many formulas which were not even proved at that time, and professors were so.
Yeah. So one of his main area is what is called partition function. Okay.
Yes.
Now, what is the partition function? And we will come back to it later on also. But basically, if I give you a number n, an integer n, okay, what is the integer? It says like number 5. Okay. Now I said, how many ways can you write 5 as a sum of integers? So you can write it as, okay, I can write it as 1 plus 1 plus, 5 ones added, right? So this is one way of writing it. I can write it as 3 ones and 1 2. The second one of addition. I can write it as 1 1 and 2 2. The third one of addition, right? And so on and so forth. I can write this as 1 1 and 1 4. That's one way of writing it. So, or 2 1s and 1 3. So there are a number of ways you can write 5 as a sum of integers. Okay? The simple question is that, can you tell me, if I give you a number n, how many ways can you write that integer n as a sum of small integers? In later on in the course, when we will be doing combinatorics, we'll see how hard this problem is. And Ramanujan's great work was actually that he came up with a solution or a weird looking formula which gives you this number. Now, so of course he claimed various crazy stuff that some goddess came and gave him the solution and all those things. But it was true that somehow he had produced something and he could not prove it, by the way. He could not prove that his solution was correct, but it was correct. And then, so it was a lot of hard work to prove formally whatever he has done and all. And how did he come up with this thing? This formula is so crazy that it is hard to imagine. I usually flash that formula at some point of time in this course. I will do that. And basically, now we know after many years that we have a proof. And the main idea is that he comes out. This comes from the Fourier or harmonic analysis. Something that is hardcore mathematics, nothing to do with discrete. He somehow, although that whole subject was not developed there, but he could internalize that and finally end up proving that in that structure. So he started with a very discrete object, a problem that is purely discrete, but the solution goes via a very complicated mathematical concept. Okay. This is something that you will see again and again and again in your discrete mathematics. Okay. The same thing that if you are so something like number theoretical problems, like I don't know how much you guys are familiar with, but things like how many different twin primes are there? How many of you have heard of this object? How many different twin primes are there? You know what is the twin prime? A twin prime is a prime that's the difference 2. Something like 11 and 13. Okay, 29 and 31. Right? So similarly, so can you say that the number of twin primes is infinite, or is there a finite number of twin primes? Right? So these questions are all very discrete math, right? Simple discrete math stuff. But the solutions can go very far. Solutions usually take some very complete convoluted route. So if you are, I mean, there's a guy called name of Terence Tao. He's a like super big name in this field, and he's been working on all of this stuff. There's some Indians also in this field, in this work who work on this kind of discrete math objects, but solution is through continuous, some continuous stuff. Yeah. So yeah, so many of you are writing about what is the exact thing that Ramanujan did. Yeah, Ramanujan did a lot of things, no doubt about that. But actually, his biggest contribution for which he is known in the mathematical world is this: is prime number theory, partition function. We will talk about it later on. But the reason I brought it up is that these are examples of discrete math objects where you solve it using non-discrete math techniques. Okay, so this is something that we will see a lot in this course also. By the way, let me start. Okay, so now the main idea is that every problem, again, this is a kind of repetition of what we have told. Okay, so every problem that has to be solved is a unique problem, and there is no fixed algorithm for solving it. Okay, I cannot say that, oh, okay, go and do this one and you have solution. Okay, we might have a vague overall idea how to approach it, but that's about it. Okay, so the only way you can understand how to solve them is by solving more and more and more problems, and your job is to kind of know which techniques can be used, a lot of creativity in this part and so on, that will help you in solving that particular problem. Okay, so this is a vague overview of whatever we will have. And if you don't have any more questions, in the rest of the class today, which is say I will take another 20 minutes or so, I will kind of go over quickly something that you possibly have seen. I don't think I will go over propositional logic, but let me go over at least sets, relations, and functions. Okay, so that we are all sure we are in the same page. At least you'll be introduced to these notations and notions and all, and so that we can start properly from the next class. But before I go into it, is there any questions, any doubts, anything related to this stuff that we have done so far that is you want to ask, or you want to comment on something?
Sir, I'm Orithro. May I ask you something related to this topic?
Yeah.
How would you define set beyond elementary definition?
I have not yet defined it.
No, I'm just asking you. This is a question to all of you. Yeah.
I don't know what you mean. I have no idea, and no, this idea we can talk about it later. Okay. Yeah.
Thank you.
Okay. Yeah. So any questions other than yeah, so far? Okay. So let's continue. Okay. So this one will. So again, rest of this lecture will be pretty simple. It will not be complicated because you have seen most of it. So let's see. Let's start with